Hi everyone, now we are going to discuss about the differential protection, that is in third module second part. So in this type of protection we are going to discuss the how to identify the internal fault. So usually by comparing the electrical conditions in the electrical equipment, that is entering current and outgoing current, okay, leaving current. So we have to measure the difference between that and we have to protect our electrical equipment. It is most sensitive and effective method for this protection. The main principle for this protection is that detecting very small magnitudes of the differential currents, and the disadvantage is that it requires currents from the extremities of a zone of protection, which restricts its application to the production of electrical equipment such as generators, transformers, motors of a large size, bus zones, reactors, capacitors, and etc. Okay, the differential protection relay, which operates when the phasor difference of two or more similar electrical quantities exceeds a predetermined value. Is it clear? A preset value, if it exceeds, it measures that values, and that difference by using that difference, relay start operating. Most of the relays are of the current differential type of relays. You know that different types of relays already studied in the first module, right? So here the relay compares the current entering a machine winding and leaving the same under the normal conditions or during any external or through faults. Okay, the current entering the windows is equal to the current entering the winding, but in case of an internal fault on the winding, these are not equal. Is it clear? This difference in the current actuates the relay start operated, so that relay operates for the internal faults and remains inoperative under the normal conditions, or it may be external faults. In case of bus zone protection, CTs are placed on both sides of the bus bar. Okay. See, a pair of identical current transformers are fitted on both sides of the protected element, which equipment you are going to protect it. Okay, the CTs are of ratios that their secondary currents are equal during the normal conditions or external conditions. The secondaries of CTs are interconnected by a pilot relay circuit in an instantaneous overcurrent relay. While connecting the CTs, we have to take main care is that a dot polarity, that is nothing but to the dot means polarity marks placed on the CTs. Okay, we have to take care that about the polarities on the CTs. In order to trace the direction of the currents, we have to follow some rules. That is, when the current enters the dot mark on the primary side of a current of the CTs, the current must leave the similar dot mark on the secondary side. Is it clear? First rule is, current enters the dot mark on the primary side of the CTs and current must leave the similar dot mark on the secondary side. The polarity connection of these CTs are that their secondary currents are in the same direction in the pilot wires during the normal conditions or during the external faults, right? See, all type of differential protection scheme are generate a well-defined protected zone which is accurately determined by the location of the CTs. See, for the extra high voltage, ultra high voltage transmission lines where the terminals and the CTs are widely separated by the distances, so it is not practically possible to use differential relays as we have discussed. Okay, so that this differential protection principle provides the best protection and is widely used for the extra high voltage and ultra high voltage transmission lines. Okay, see here in the differential protection, we are going to discuss the type of the differential relays. That is, a differential relay is connected to the overcurrent relay, which operates when a phasor difference of currents at the two ends of the protected element exceeds a predetermined value. So there are these are the what types of the differential relay: simple, basic, percentage or biased differential protection, or balanced. We can call it as an opposed voltage protection, differential protection. Now I have to discuss the simple type of differential protection. We call it is the bias differential protection. Okay, in this type of protection we are going to compare the phasor difference of the currents at the two ends of the transmission line. We have connected the CTs, right? The second is of CTs detect the whatever the difference between that entering current and outgoing current, that phasor difference we are going to calculate it. If it exceeds the predetermined value, preset value, the relay start operating. Okay, see here the CTs of the secondaries CTs we have to connect through the pilot wires. Okay, secondaries of the CTs connected at the both ends of the transmission line. We have connected these two by the pilot wires, two pilot wires. Okay, the operating coil of the overcurrent relay is connected at the middle of the pilot wires. Okay, see here in this figure you can get the clear picture. See here the whatever the first CT and second CT, the second of these CTs are connected through the what? Pilot relay. First one, second, two pilot relays are there. Okay, these two pilot relays are carrying that what? Operating coil of the overcurrent relay. This is connected middle of the pilot wires. The second of these are connected to the pilot wires. Okay, the behavior of the simple differential protection during the normal condition we are going to discuss. During the normal condition, what happened? Usually the both side currents should be equal. I1S sending in current at this side, and here the secondary current is what? I2S. Both are equal. Therefore, I1S equal to I2S, or we can write I1S minus I2S is equal to 0. It is in the normal condition or during the external conditions. See here they have given the conditions, right? So this is what a simple differential protection. The CTs are the ratios of these CTs secondary currents are equal under the normal conditions, or it may be external conditions. The protected element equipment is usually 1:1 ratio of the transformer or generator winding or bus bar. The two currents on the primary side will be equal under the normal condition or external condition. Hence, the ratios of protective CTs is always identical. Right, the figure shows the combination of two CTs and the overcurrent relay action here. The overcurrent relay operating coil is connected here middle. The normally open contacts of this overcurrent relay are wired to trip the circuit breakers here. When it detects the signal a difference, that sends the signal to the circuit breaker, and circuit breaker trip the circuit. Okay, here the secondary currents I1S, I2S of the both CTs are equal. Okay, equal to the what? Usually load current. Load current is what? IL dash. Okay, here IL and here load current. I1S equal to I2S is equal to load current IL dash. The secondary currents under the normal conditions simply circulate through the secondary winding of the two CTs, and pilot leads. The instantaneous overcurrent relay is connected here middle. Okay, the overcurrent relay does not operate to trip the circuit breaker under the normal and operating conditions. This protection we can also call as circulating current differential protection scheme or MERS price protection scheme. The boundaries of the protected zone is determined by the location of the CTs. Is it clear? Okay, both sides the secondary current are equal to the load current. That is what here we are going to see the simple differential protection. Usually CT ratio is 1:1. Okay. Next, behavior of simple differential protection during the external faults. What happened during the external faults here? I1 equal to I2 equal to IF. Therefore, I1 plus I2 divided by 2 is equal to IF. How it is possible here? See the diagram. An external fault occurs outside. External faults here they are showing outside occurs. Under this condition, the zone of protection is outside. Okay, the CT's location is here, but the fault is occurs here outside the CT's location, out of the zone of the protection. Here fault occurs. Okay, as in this type of case, normal conditions or external condition, the current through the operating coil, this is what middle current operating coil is 0. Current through through this operating coil is 0. The secondary current I1S and I2S of these two CTs, secondary current flowing through the operating coil of the overcurrent relay. Okay, that is equal to the faulty current IF dash, right? The whatever current is flowing through this is that is equal to the whatever current is occurs during the faulty condition, that current is flowing through the operating coil, and the differential spill current, that is I1S minus I2S, flowing through the operating coil, that is the faulty current of this, okay, that through the operating coil of these current or current relay is 0. Okay, hence the operating coil does not operate under the external condition. Is it clear the condition here? The secondary currents I1s and I2s of the CTs are equal. I1s equal to I2s. Therefore, I1s minus I2s is equal to what? 0. Whatever faulty current is there, that should be 0. That faulty current should flow through the current coil. But here, I1s, the secondary current here and this secondary current both are equal. This fault occurs out of the zone. There is no faulty current inside here. That is nothing but secondary current of this, but here both currents are equal. There is no difference in the current. If there is a difference in these two currents, that should be flowing in the operating coil. Hence, there is no difference in this current. There is no current flowing through the operating coil. This is the what? During the external fault. Okay. If the internal fault occurs, internal fault means the whatever CTs are connected, CT1, CT2, if the fault occurs between these two points. Okay, and this is transmission line, right? Equipment is connected. If the fault occurs here, what happened here? Here, this is a, it is also like similarly like a differential, simple differential protection scheme. During the internal faults, what happened here? A single end fence. It is like a, for internal fault, it is like a single end fed. Okay, means what? Internal fault occurs inside the inside the protected zone, that is within the CT locations. In this case, internal fault, the current entering protected zone is I1. Okay, the current is I1 here, whereas the leaving current is what? I2. Also that whatever current is I1, current I2, both are not equal, because what? Middle is fault occurs, right? I1 is not equal to I2, but I1 is equal to what? Middle current is what? IF, fault occurs here, IF plus I2. Is it clear? I1 is equal to IF plus I2. That is, I1 is not equal to I2. Hence, the two secondaries current, I1s, secondaries of this CT current is I1s, and here is I2s, secondary current of this CT is I2s. Both are not equal, so that there is a difference occurs between the secondary of these two currents. That difference should flow through the what? Operating coil. That difference we called as the IF dash. That difference between the secondaries of these two currents is flowing through the operating coil. The relay, so that the relay detect the extra current, that is, it is more than the predetermined current difference, it should detect it, so that relay start operating it and it sends the signal to the circuit breaker trip the circuit. This is what? If fault occurs within the zone of protection, within the CT's location. If an internal fault occurs in a double end fed system, that is in the next figure, see, this is one end fed. Okay, if see here, both two end fed, double end fed system. This is showing the figure, double end fed. The right hand current, whatever we are just now we have shown the figure, that is reversed, and both pilot currents I1s and I2s add and flow through the operating coil. Is it clear? The right hand, okay, this side current, previous figure has shown that this end current is reversed here. Reverse aitandre enagatta, this current should add with the left hand side current. Therefore, I1s plus I2s. Is it clear? So that much current, I1s plus I2f, whatever current is there, that is, if it is more than predetermined value, that extra current start flowing through this operating coil. Okay. So that here right hand side current is I2. In case of internal fault is either very small or 0. Left hand current dominates the differential current. If it more than this side, so that it will show the I1s minus I2s, that current flowing through this coil. Okay. So if it is higher than the predetermined value, relay start operating it. Okay. This is what double end fed. Okay. Is it clear the difference of previous one and this one? This is the what internal fault occurs, what happened here. The protected zone differential protection scheme we are going to see in the next video.